Okay, so in your notes, write writing and graphing inequalities. And these are some Google images I was able to find. This must be a TV show. Has anybody seen this one?
Oh, yeah.
Okay. And here's one that's more common, like you're at Walmart or something, and they have these signs that say 12 items or less. Like you can check out there. It's supposed to be the speedy place to check out because people don't have that many items. And then there's this one. It seems to be a football saying or something. I've never seen it before, but.
Oh, four is probably Brett Favre. It's Brett Favre's number.
Oh, it's a Favre thing. All right, there we go. Aaron Rodgers is greater than Favre. That's all right. I get it now. Okay. I'll move it so you don't have to see it anymore. Wow. Okay. Didn't know it was an anti-Vikings thing there. So okay. So the jelly beans are just an example I'm going to use later, and besides, I was kind of hungry when I was making this. So let's move on. Define a variable and write an inequality to model each situation. These are simple ones. So we start with baby steps. You learned this like in a whole day last year. You're going to learn it in 5 minutes here. The ages in this class are greater than 11, but less than 17. Well, I could say age is greater than 11, right? And I could say age is less than 17, right? But who can put them together all into one neat little package? Apparently the guy in the red shirt can. Okay. Jacket. Go on. But thank you for trying. Start again. Nope. Okay. Yep. And the only reason I don't like it the other way is this is intuitive. It goes from the smallest number to the biggest number. And in math, we do need to keep consistent on that because we can write this in another way. Have you seen interval notation before? You remember how we could write like 11, oops, and we can't start with the big number. We're supposed to start with the small number here. 11 to 17. And then you put parentheses around it if you don't actually get to them. What do you put around them if you actually get to them? Brackets. Good. Okay, so what if I change my problem to this? It could be the ages in this class. I'm going to say it's okay to be 11 years old and be in this class. We do have some awfully young kids taking this class. You know that come from the middle school. So there's like 5, but I don't think he's even the youngest. There's somebody younger than him. So, but anyway, moving on. If I change that, I need to change this to what? A bracket. All right. Next up, 15 items or less. How can I write that? I less than or equal to 15. Very good. Next one. Right now, I don't have enough. That's pretty vague, but you could still write something. Yes? You don't like the I for this? Because? So I is defined in the square as -1. That's good. That's an imaginary number. But if I want to use I can use I. I suppose I could change it to an A just to make you feel better. Okay, next. I don't have enough. So the amount that I have is less than enough. I like it. It was vague, so we can write a vague answer. Next thing, when you add my money to yours, we'll have at least $200. Well, I have to define a couple variables here, right? I got to say my money's going to be X. Okay, maybe I'll put it there. Then your money's going to be Y. Y for yours, that makes sense. And then what do I say? There you go. Now you're writing inequalities. That's all there is to it. You've done that before. Okay, moving on. Here are some things I'd like you to take down. The ones that are obvious, I don't need you to write in your notes, but in your notes, please write the ones that are not so obvious, like these two going with this one. Not less than often confuses people. Below is pretty obvious, I think. Below means less than. Fewer than, those are all pretty obvious. Not greater than means less than or equal to. Or I have up to 10 people can come. That's less than or equal to. All right, so those are some common words that you're going to run into, and you'll need to be able to write the equations for them. So let's move on. Do you need any more time to write? I guess you need more time. I'll pause for a second while you write those down. And we're back. If we were going to graph these, they're all a little different. This first one is notable because it's solved for y. That's the way that's easiest, because it's easiest to graph them like that. Okay? Now, this kind's a little different because it isn't solved for y. You can still graph them. Easiest way is just to solve it for y and then graph it. Right? This kind doesn't have a y in it, but I can still graph it. It'd just be a line. Is it a horizontal line or a vertical line? It's a vertical line. Okay. Next, let's actually look at one we actually have to solve. This one is not solved for y, so I'm going to divide coincidentally by a negative, because I want to remind you of something. If I divide everything by that negative, y, switch the sign, you got it, greater than or equal to x, and then that's supposed to be a minus 3. And that's supposed to be a negative x, actually, because there's 2 divided by negative 2. All right, there we go. So now, the question is, if I'm going to graph this, should I use the solid line or the dotted line? It's the way I would think of it is, if I graph, when I graph a line, I want to have the things that are on that line, they either work or they don't work. Okay, so let's do that and test it. So it's either got to be this one where I'm going to go through negative 3 like that and have a slope of negative 1. And if it's solid, does that seem like it's filled in or like it's empty? A filled in line. This is like an empty line. Now, why do I use that example? Because when you were graphing these in the old days, you were graphing them with like a 2 here, and you'd have a circle around. If I said x is greater than 2, you'd just go, oh, the numbers that are bigger than 2, and you'd shade this direction, and you would leave that empty. But if I said it could be equal to 2, then you'd have to fill it in, right? You fill in the areas that could work. Same idea with your line. You're filling in the area that could work. So the question is, would the stuff on the line work or not? So I'm going to pick a point. This point right here would be at 0, negative 3. If I stick that into my equation, I stick in x is 0 and y is negative 3. Let's be careful with our negatives now. It's negative 3 is greater than or equal to negative 0 minus 3, which is negative 3. Is that a true statement? Yes, so the things on the line, do they work? So I should shade them in. So I should use a solid line. You're right. Okay. The dotted line is saved for things that are just less than or greater than, not or equal to. All right. Now, which way should I shade? Well, this one says greater than, up to here, greater than, so you shade above the line. So it's just shade this way. Now, instead of like shading everywhere like this and your paper getting all messy, I recommend that you just shade a little bit like this, just a little bit on one side of the line, because we're going to be graphing a whole bunch of lines at once, and we want to see where they all overlap each other. And if you shaded your paper already heavily with your first one, then it's really hard to tell where all 3 of them or 4 of them overlap. All right, moving on to the next page. Here is the graph for that one. Is dotted line, is that appropriate for this? Yes, it is. All right. Here's another graph that's being added to that first graph, and they've shaded it. It's got a solid line. Is that appropriate for that one? Yes, it is. Now, where they overlap is, well, we're going to see where they all overlap in just a second. Here's the third one that we've graphed. X is less than or equal to 6. So there's the line. X is 6. It's right here. Kind of looks like the axis, and it's a solid line. And then when you put them all together, you get that. And the feasible region is the place where they all overlap. And if we take a point from that feasible region, like this point right here, 4, 4, if I want to test it, it should work in all my equations. So if I put in 4, 4 here, 4, 4 here, and 4 here, let's just double check that. Is 8 really greater than or equal to 4? Yep. Is 4 less than 12? Yep. And is 4 less than or equal to 6? Yep. So it works in all of them. Check, check, check. And therefore, that's where they all overlap. Those are the special points. All right. That's all there is to it for today.